All right, so when we have fractions that we want to add together and they don't have a common denominator, we have to find one, right? And in order to find that common denominator, we need to take a look at the denominators and decide what their least common multiple is, right? And we call it the least common denominator, right? But the least common multiple is really what you're finding. So I want to get some practice doing that even before we actually do the operations of adding and subtracting two fractions. So just finding that least common multiple. So I've got a few directions here for us. So when we're looking at polynomials, or even just numbers, the least common multiple, or LCM, of two polynomials can be found by factoring each polynomial completely and then listing each factor the greatest number of times it occurs in either factorization, right? So you want to make sure you include all the factors, and if there's like an x squared and an x, then the x squared is the one that you would include in the LCD. Okay, and then find the product of all of those things and list that as the LCM. Okay, so let's give this a shot. Okay, so first of all, before we even start with polynomials, I just want to start with a couple of fractions like 1/12 and 5/16, okay? Something where the numbers are a little bit bigger but not too huge, and see if we can find the least common denominator. And the least common denominator, or LCD, is the least common multiple of the denominators, right? So let's do this. So for the first example, 1/12 and 5/16, if we're trying to find the common denominator between those two fractions, we have to find the lowest number that both of those numbers will divide, right? So sometimes if the numbers are small enough, you can just sort of think about that in your head, like, well, what's the first number that I get to that's a multiple of 16 and also of 12, right? And the other way to do that, if you're working with numbers, is to look at their factors. So I want to look at the prime factorization of both of these. So like 12, we can split that up into 2 times 6, right? And then 6 is really 2 times 3, right? So we have 2 times 2 times 3, or 2 squared times 3 as a prime factorization. And then with 16, 2 times 8, right? 8 is 2 times 4. 4 is 2 times 2. So 16 is 2 to the 4th, right? Okay, so you have to take all the factors, right? We have two factors essentially, right? 2 and 3. But with the 16, it appears 4 times, right? And it only appears twice with the number of 12. So if we have our choice between 2 squared and 2 to the 4th, pick the one with the bigger exponent. So 2 to the 4th times 3. Okay. And 2 to the 4th times 3 is, 2 to the 4th is 16, right? So 16 times 3, 32, 48, right? 48 is also a multiple of 12, right? Some of you could look at that and kind of get there in your head, right? If you just keep adding 16, you get to 48 pretty quickly, right? So, but I wanted to go through the factors just because as we start working with polynomials, hopefully it'll be easier to see what we're doing. Okay, so with this next example of 7 over 12ab and 5 over 6a squared. Okay, so I'm looking at the numbers 12 and 6, and the lowest number that they'll both divide is 12, right? And then I have, what other factors do I have? I have a and a squared. So a squared is the one that goes in the LCD, and then also b, right? So I have to include all of the factors that I see, variable factors, the largest number of times that they appear in any given denominator. Okay? All right. Now, in this next example of 3x over x squared minus 4 and also x plus 1 over x squared plus 2x, I want to factor those denominators, really figure out what those factors are. So in this first example, I'm going to have 3x over x plus 2 times x minus 2, right? It's the difference of squares. And then with this other fraction, I'll have x plus 1 over x times x plus 2, right? You can factor an x out there. So in looking at both of these denominators, list all of the factors that you see. So I'm going to have x, x plus 2, and x minus 2, right? And the x plus 2 lives in both of those denominators, but it only appears once, right? Like if I had an x plus 2 quantity squared on one of them, then that's the one I'd want to include. But it only appears once, and so you only need to list it once in the LCD. Okay? All right, so now let's look at this one. 1 over 4 squared plus 20x plus 25, and 1 over 2x squared plus 5x. Okay. So again, I'm going to do some factoring here, right? So with this first one, 4x, I notice the 4x squared and the 25, and I think they're both perfect squares, right? So I think this might be a perfect square trinomial. Let's see here. We've got 2x plus 5, right, times 2x plus 5, just taking the square root of 4x squared and also of 25 there. And let's see, 2x times 5 is 10, so I'd have that as my outer and my inner term. 10 plus 10 is 20, so that works. Okay, and then over here, I can pull an x out, right? So 1 over x times 2x plus 5. Okay. So I have the factor of x, and I also have 2x plus 5, but it appears twice in the first fraction, right? So I have to include it twice in the LCD. So I have to include it the highest number of times that it appears in any given denominator. It appears twice in the first fraction, but only once in the second fraction, so I include it twice in the LCD. Okay, hopefully this will become a little bit clearer as we go on and do some more examples.